Today we'll be starting a new topic called trigonometry. But what is trigonometry? Does anyone have any ideas as to what it could be? No, right? Something to do with shapes. Close. It does involve a specific shape. Doesn't involve triangles. Excellent. So the word trigonometry comes from the Greek words for triangle and measure. We use trigonometry to explore the relationship between the sides and angles of a triangle. We can use it to determine unknown side lengths and angles. It can be applied in fields such as land surveying and architecture. Today we'll be exploring the relationship between the sides and angles of a right-angled triangle using what we call trigonometric ratios. In trigonometry, there are four terms that you'll hear being used a lot. These are the hypotenuse. This is the longest side of any right-angled triangle and can be found opposite the right angle. We have what we call our reference angle, which you might hear being called angle theta. We use this angle to help identify the other two sides. We have the opposite. This is the side that is opposite the reference angle, and the adjacent, which is the side that is next to the reference angle. So now in trigonometry, we use three ratios to help us explore the relationship between the sides and angles of a triangle. We call these ratios the trigonometric ratios, and each ratio relates to a pair of side lengths. These ratios are sine of theta, which we take by dividing the opposite by the hypotenuse. We can also write this as sine theta equals O over H. The second ratio is cosine theta, which is equivalent to the adjacent divided by the hypotenuse. This can be written as cos theta equals A divided by H. The final ratio is tangent of theta, which is equivalent to the opposite side divided by the adjacent side. This can be written as tan theta equals O divided by A. Now we can help remember this using a mnemonic called SOHCAHTOA. So S sine equals O divided by H. C cosine is divided by A, equivalent to A divided by H. And T tangent is equivalent to the opposite divided by the adjacent. But how do we use these mathematically? Now, let's say I take a right-angled triangle. We have three side lengths, 13, 12, and 5, and our reference angle marked. To work out the three ratios, we first need to know which sides are the opposite, the adjacent, and the hypotenuse. So we draw our triangle, write in our side lengths, mark our reference angle, and then work out which ones are the opposite, the hypotenuse, and the adjacent. Now we know the hypotenuse is opposite the right angle, so it must be this one on the top. The opposite is opposite to the reference angle, angle theta, so it'll be side length 5 there. And the adjacent, we know will be on the bottom because it's next to the reference angle. From there, we will write down our trigonometric ratio. So we have our sine theta equals opposite divided by the hypotenuse. Cos theta equals adjacent divided by the hypotenuse. And tan theta equals the opposite divided by the adjacent. To finish calculating the ratios, we then substitute our values for the opposite, adjacent, and hypotenuse into the formulas. So that gives us sine theta equals 5 divided by 13, cosine theta equals 12 on 13, and the tan of theta equals 5 on 12. Now, I've chosen to leave these as fractions because that gives us a more exact value than a decimal. So, a few more examples. Now, as you can see on these two examples, we only have two sides marked, and one of them includes a pronumeral. But the methods we use will be the same. So in these cases, what we want to find out is which ratio to use. In our first triangle, we have two sides, 15 and 6. We'll first want to label these sides, so we know that one is the hypotenuse because it's opposite the right angle, and this one is our opposite because it's opposite the reference angle. We then determine which ratio to use. If we look at our ratio, SOHCAHTOA, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over the adjacent. Now we have our opposite and our hypotenuse, therefore we know to use the sine ratio. So sine theta equals opposite over hypotenuse. We substitute in our known values, so we have our side length 6 and our side length 15. So sine theta equals 6 over 15. We then simplify this down to 2 over 5. Now with our second example, we have our angle theta is given as 50 degrees. We have two marked sides, so we have 18 and x. Now, our hypotenuse opposite the right angle hasn't been given a value, so we know not to use this. So that leaves us our opposite and our adjacent, which I've labelled here. The ratio that uses opposite and adjacent is tan of theta. So we'll write down tan of theta equals O over A, and then substitute in our values, or in this case pronumerals, which gives us the tan of 50 degrees equals x divided by 18. Alright, so now I've put two examples up on the board that I would like you all to work through. So I'll give you a few minutes to do this before I call out for answers. So, now in completing these examples, was everyone able to find a sine ratio, a cosine ratio, and a tangent ratio? So, I'll get you to put your thumbs up if you were able to, thumbs down if you weren't, and horizontal if you found some of them. Good. So most of you are able to find each of the three ratios. With the first example, what was the ratio for sine of theta? 2 over 5. Good. And the ratio for cosine of theta? 3 over 5. Excellent. And tangent of theta? 4 over 3. Which you weren't sure about that one because it was higher than 1. That gives us a interesting point with these ratios. Now, you'll find that the cosine and sine ratios, they'll always be below 1 because we're dividing by the hypotenuse, which is the longer side. But the tan ratio can be above 1 if the opposite is higher than the adjacent. If, say, the opposite is shorter than the adjacent and your ratio for tan is above 1, that's a good check to see maybe you've done something wrong. Now, with the second example, good, so we've got sine theta L over G, cosine theta H over G, and tan theta L over H. Excellent.